Today we're going to talk about how to graph these by hand. So first, let's write this down. F of x equals a sine bx. And that a right there, hopefully you realize from the worksheet that that corresponds to the amplitude. So to formalize it, we're going to write the absolute value of a is actually the amplitude. And for the b, hopefully you realize from that worksheet that it relates to the period. And the relationship is this. The absolute value of 2 pi over b is equal to the period. So make sure you box that. That should be in a nice place in your notes. And we're going to start by graphing this basic sine graph. So I just copy and pasted this t I have. I recommend you do that too. It just makes it faster when you're working. You're going to put 0 right there in the middle. That's your x-axis, and I'll put x right there. You don't have to. It'll be implied. I'll put y up there. The amplitude here is 1. So you're going to write that. A equals 1. Now the period, notice how there's a 1 in front of that x. So we're going to write 2 pi over 1, which is 2 pi. Now we're going to use that to scale everything. So the amplitude means you're going to go up 1, down 1. Now for the x-axis, the way this works is you're going to put 4 tick marks evenly spaced. 1, 2, 3, 4. The fourth one is a little bit bigger because you're going to make that this period value. That's 2 pi. Now what you do is using this fourth one, go to the second one next because that has to be half of 2 pi, which is pi. Now go to the first tick mark because that's half of what you just did. Now that's pi over 2. And now the third tick mark, think of this one, this times it by 3, and you get 3 pi over 2. Now we graph it. Sine starts in the middle, so put your dot right there, and notice how it's just going to go up because it's positive. So there's the first point, next point, next point, next point. And sine graphs and cosine graphs are really nice to graph because they're very predictable. They're always going to be evenly spaced, and they're going to increase and decrease in the very same way. It's very pattern oriented. So now here's your graph. I'm going to label my points. So that's 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. This is one period, and of course, because this goes on forever, so if you wanted to, you could illustrate that this continues indefinitely. But for our class, we're just going to graph one period. Now it says domain and range. So domain is actually all real numbers because of what we just said. This graph continues indefinitely, so this goes on forever. Now the range is going to be from negative 1 to 1. And we can see that the lowest point is here, the highest point is here, and the graph constantly oscillates between these two forever. So there's our first graph. Now let's go to cosine. So the pattern you're going to follow is you want to identify your amplitude and period. So A is once again 1, period is once again 2 pi. Then you're going to want to have your t. So here's my t. Now label 0, 1, negative 1, 1, 2, 3, 4. Your fourth tick mark is your period, 2 pi. And now I just scale appropriately. Pi, pi over 2, 3 pi over 2. Now the difference for cosine is cosine typically starts at this top value, this 1. So now I just continue the pattern. And there's our first wave. Try to make it as smooth as possible. You don't want any jagged edges here. Now I'll label 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. Our domain is once again everything. And the range, same as last time, -1 to 1. It's not too bad. So for our next two examples, they're going to be a little bit more difficult. So let's try it. A is equal to 3. The period is 2 pi over b. It's 2 pi over 2. So that would be pi. Now we're going to put our t in right there. Label 0. We're going to go up 3 and down 3 this time. Go 1, 2, 3, 4. The fourth tick mark is pi. Now scale appropriately. And now we're going to graph. So sine starts in the middle. So set your point in the middle right there. Notice how it's positive 3. So it's going to start by going up. And now just follow the pattern. Let's label 0, 0. Pi over 4, 3. Pi over 2, 0. 3 pi over 4, -3. And pi 0. Our domain is everything. So you'll notice that the domain for all of these will be everything. And the range is simply -3 to 3. Last example. A. P at this point you should feel pretty comfortable. 2. Let's go straight to 4 pi, because if you're dividing a fraction, you multiply by the reciprocal. Let's put our t right there. So 0, 2, -2, 1, 2, 3, 4. Fourth tick mark is 4 pi, which is nice because that means every tick mark is simply pi. Now this one's going to be a little different. Normally cosine would start up here, but notice how it's negative, which means it's going to flip it. So the first point is actually right there on the bottom. And now we just continue the pattern of the wave. And there we have it. There's our cosine wave. Let's label 0, -2, pi 0, 2 pi 2, 3 pi 0, 4 pi -2, and there it is. We can put domain and range right below. Domain is everything, and the range is -2 to 2. Now let's do a couple summary tips here. For sine on the left, notice how all the signs are starting in the middle. So I'm going to put a big star here. Star. Sine starts in the middle. And that's true no matter if it's positive or negative. And that happens because sine of 0 is 0. So no matter what, because of this factor right here, you're going to start at the origin. Now cosine's a little bit different. Notice how on our first example, cosine started at the top, but on our other example, cosine started at the bottom. So for this one, we're going to put a big star here. We're going to write cosine starts at the max or min, and that depends if it's positive or negative. Now for the final example, it says, decide which of the following choices is equivalent to the original statement and circle. Draw a picture to show your work and to prove your answer. So here we have another one, or cosine of theta plus pi. So we've kind of done examples like this before. Think about the circle, and I'll draw it generically in quadrant 1 here. Let's say that's your theta. Cosine is an x value. Recall that pi is 180 degrees, which means you want to rotate this angle straight across. Now think about the x value. What has happened? Well, it's positive here, and if it rotates 180 degrees, it's now the negative x value. So the answer is this one right there, 2. Now the second one, this one is not really much to draw. Hopefully you just remember sine of pi over 2 minus theta, that's an identity. That's cosine of theta, just like cosine of pi over 2 minus theta. That's equal to sine theta. So quickly just recall this identity and write that down. Those are your cofunctions or cofunction identity. So the answer here is clearly 1 cosine theta. Now the one thing to be careful of is I'll give you an extra one. Let's say it was sine of theta minus pi over 2. That's a bit trickier because you notice that these are switched. So if they're switched, you have to factor a negative out. So now it looks like this. And because sine is odd, you can then take it out. So now I have negative sine of pi over 2 minus theta, which would then reduce to negative cosine theta. So that's how you can make this identity a bit more challenging just by switching it, but then it's easy to handle because you factor the negative and you take it out.